Welcome back, Controls Champions, to another recipe in the PLC Programming Cookbook. Today we're going to do another example on a three-way light switch, but I'm going to go way beyond what I've done before, and I'm also going to do it in structured text. Just to reintroduce the topic of a three-way light switch, think about like a hallway in your house where you're controlling a light from both ends of the hallway. So you've got two different switches. In house wiring, we would call those three-way switches, and they're special switches with two contacts in there it's single pole double throw. It's the electrical term. And if we want to do more than two of those that control the same light, we would use what's called a four-way switch. So what we're doing here is simulating that same kind of functionality in the PLC using switches that have a single contact, so single pole, single throw. So we only have one input to the PLC from each switch. In past examples, I've done two switches and three switches. In structured text here, I'm going to show you something that's a little bit new, and it's really quite simple. So I can do 9 switches. I could do 32 switches if I wanted, and this logic wouldn't change. This is all the same. So how do I do that? Well, first of all, rather than having a tag for each one of these switches, I have a tag that's not a Boolean. It's not on or off or 1 or 0 like a switch needs. It's a full DINT. This is a double integer. It's 32 bits. And each one of these switches, you can see, is addressing 1 bit out of that DINT, out of that double integer. So if I'm going to click through these switches, keep watching this number here. You'll see it. That's the only thing that changes. So 0, 1, 2, 3, and so that's saying in this program, ST three-way is the name of this program. The variable name is switches, okay, switches right here, and the bit number is 3. Bit number 4, bit number 5, bit number 6, 7, 8. And we could continue this all the way up to the maximum number of bits in that DINT, which is going to be bit number 31, because we start at 0. We start counting these bits at 0. So 0 through 31 is 32 bits total. The way that we're doing this, saying that whenever I toggle any of these switches, I want that light to toggle, is very similar to what I demonstrated in ladder logic here, where we're watching for state change and then making a toggle one-shot bit off of that we would toggle again off of that. Same kind of idea. I'm saying if switches, this DINT that contains all of our switches, is different than it was last time I saw it, then we're going to make light whatever light is not. We're just going to toggle the light. And then at the end of the scan, each time we say switches last we're going to dump switches into that. So we're remembering what it was last time, and that's how this can work. So that's a lot more simple, a lot more compact, and I think it's darn readable as well. Sometimes you got to be careful when you're making something really short and compact and simple. Maybe it's not logical, it's hard to understand, but this isn't that at all. I think this is very clear what it's doing. And of course, if we were making this in a full-size program, we would be commenting and organizing things as well. So let's simulate this and see if it works the way I promised you it would. I toggled one switch, the light toggled. Toggle another one, it went off, and I should be able to just keep on toggling through here. Doesn't matter what switch I switch, doesn't matter where it goes to. And notice that switches here, this tag, this variable that is storing all of these bits, that number is changing. And it's changing because we're changing the value of the bits inside that tag. So we could even sort of count up by binary here. It starts at 0 when they're all off. If I turn on the 0th bit, the very first one, it's 1. What if I turn on the other bit? That's 3. The next one should be 7, because this is just how binary counts up, right? If we've got the first 3 least significant digits in binary turned on, the value in decimal is 7. So whenever that number changes, we're going to toggle the light, and this will work perfectly for any number of switches that we could add to this, as long as we don't run out of bits in those DINT, bits in that DINT. Otherwise, we would just have to make a second DINT and monitor them both. So could we bring this back to the ladder logic concept? Yes, to some extent we could. We'd have to add another rung down here to be keeping track of the last value. Get out of my simulator here just so it's a little easier to read. We would have to record the last value. So we'd need another rung here with a move. And then we would just have to say, we would do a comparison instead of watching for rising and falling edges here. And then we could simplify this ladder as well for higher switch counts. But I would say you can't get much simpler than this structured text if you're allowed to use it for this scenario. I'd certainly say structured text is the easiest. So I hope that gets you thinking. I hope that gives you some ideas for your projects. Let me know what you think. Leave comments, questions. I will be looking for those and responding. I'm also going to give you a link in the description to download this file to play with it yourself. We're doing it in CodeAssist. This is free software to download and play with. Go to their website. You'll have to create a free account and then you can download the software. And I'm not affiliated with CodeAssist at all. I just picked this because it has nice features for teaching industrial automation programming and is free so that you can also download it and follow along with me. So cool. I hope that helped. See you next time. Thank you for amusing my American brother, John. He does so enjoy it when people watch his videos. Be a good chap. Share, like, subscribe, and comment. I'm sure he would be ecstatic to hear your impressions. Cheerio.